Hello, everyone. What is the main difficulty when thinking about antimicrobial resistance and how to address it? For me, my main difficulty that I have is having worked in both clinical development teams, one for antimicrobial agents, again, against Staphylococcus, for example, and in the vaccines developing teams, also Staphylococcus. People start thinking antimicrobial resistance, okay, the old antimicrobial agent doesn't work, so we need to make a new one. Push it through clinical development, 10 years of development. If we are accelerating this, maybe 5 years development with all the caveats. By the time we're out with a new compound, there is already a resistance pattern existing out there and spreading with increasing use of this antibiotic. Why is that? Even new compounds, because of the nature and the way how we use antimicrobial agents, we use them when the population growth of the bacteria, of the target, is highest or very high already. It's creating symptoms. People go to the doctor, get their prescription, and you start using the antimicrobial agent. In that window, from use to cure, the population of bacteria goes down, but also has a mechanism built in that creates mutations to adapt to the now toxic environment in the human being that is treated with an antibiotic. In consequence, the antimicrobial agent can be penicillin, can be oxacillin, methicillin, daptomycin, vancomycin, you name it, linezolid, has already a mechanism built in for the bacteria to develop a mutation. And the antimicrobial compound needs to be faster than the bacteria can build up their resistance. And not only that, but also spread the resistance to the next host. What needs to be done, in my view, is both. First, of course, we need to improve the mechanisms of action, improve the safety profile of new compounds against Staphylococcus. However, we also need to work on vaccines. This is actually the first thought that I have when I think about antimicrobial resistance. If I want to develop something, I go into prevention. I want to prevent a disease so that resistance cannot even start being developed. We won't run after the events with vaccines. We prevent the infection with a successful vaccine against Staphylococcus aureus, against Acinetobacter baumannii, Klebsiella pneumonia, and others, which are the usual suspects, plus tuberculosis as well, which already has totally drug-resistant strains out there. In the end, my thinking goes, we need both. We need maybe three things at the same time. We need to think about vaccines first. We need to have a preventive way of thinking. Yes, hygiene is very important in that part as well. And we need to create a hygienic infrastructure. Vaccines, hygiene on one side. Antimicrobial agents need to be developed because not everyone can be protected with a vaccine. So this is important as well. So that in the end, when we have a good set of tools as physicians, we will be able to say resistance is futile. In the orientation on clinical vaccines development course, there is one lecture about what is the impact of vaccines on antimicrobial resistance. Seek us out, check us out on Atama Academy. You can find this under this link, https://www.atama.academy. My name is Frederick Wittke. I'm a physician, co-founder of Atama, clinical development made easy. Have a wonderful day. Bye-bye.